This is the Mars rover Perseverance, the most advanced robot to land on another planet. In this video, we'll take a look at how it was built, the Atlas V launch, the journey to Mars, and the scientific instruments that allow it to study the surface. On February 18, 2021, the Perseverance rover successfully touched down on Mars. It costs a total of $2.5 billion. It has many scientific instruments to help study Mars, search for signs of life, and prepare the way for future human explorers. Perseverance is, of course, not the first rover to visit Mars. Sojourner was in 1997, a very small rover, and here's a person for size comparison. Spirit and Opportunity in 2004, these were identical rovers sent just a few weeks apart from each other. Curiosity landed in 2012, and then Perseverance in 2021. Same size as Curiosity, but much more advanced technology. This is not a complete list. This just shows the most recent rover sent by NASA in the United States. For most of this video, I'll be focusing on Perseverance. NASA designs and builds the rovers in Pasadena, California at the Jet Propulsion Laboratory, or JPL for short. This took about 8 years of designing, building, and testing to get Perseverance ready to go. It was built in a clean room that's free from dust or other contaminants. It's designed to work on another planet, different atmosphere, different gravity, and most of all, no repair station. It has to be engineered so well that it can last for years on its own. On top of that, it has to be light and compact so it can fit inside of the launch vehicle. Once it was ready to go, the rover was carefully packaged up and then flown across the United States to Kennedy Space Center in Florida. This is where the launch happened, the same place that NASA has been launching rockets since the 1960s. Perseverance was installed along with several other components that went along for the journey to Mars. We'll talk about each one of these pieces later in the video. This was all put inside of the payload fairing, then taken to the rocket and then lifted up to the very top. This rocket is called an Atlas V. It's made by a company called the United Launch Alliance, or ULA for short. Let me point out that the rover was actually upside down for the launch. The best time to launch to Mars is about every 26 months. If we show this with the correct scale, you can barely even see the sun. For this animation, I'm going to show this out of scale so we can see this a little better. For the Earth to get around the sun, it takes exactly 1 year, right? No surprises there. Mars, on the other hand, takes almost 2 years to get around the sun. The best time to launch is right before Earth and Mars are lined up. This is called a launch window, and it happens about every 26 months. Perseverance was launched on July 30th, 2020. The 4 solid rocket boosters use up all their fuel first. At 1 minute 49 seconds, they are jettisoned or separated from the rocket. At 3 minutes 27 seconds, the payload fairing is jettisoned, which exposes the spacecraft. Next up, the main booster runs out of fuel. At 4 minutes 28 seconds, the main booster is separated, and it will fall back to the Earth. This is called the Centaur stage. Its main engine now fires up. This is what gets us into orbit around the Earth. At 11 minutes and 30 seconds, the engines shut off. This is called the coast phase. We'll stay here for about a half hour. It's a good time to check things out and make sure that everything is still working as it should. And then we relight the engines for about 8 minutes. This is called the Earth escape burn. This is what gets us on a path towards Mars. Then the spacecraft separates. It's traveling at 41,000 kilometers per hour, and it will take about 7 months to reach Mars. Our spacecraft is made up of a few pieces. Here's the rover, all folded up inside, the descent stage, this has 8 rocket engines on it, the heat shield, which slows us down through the atmosphere and protects the rover, the back shell, which protects the rover as it descends to the surface of Mars, and this is the cruise stage, provides power, fuel tanks, and thrusters, and also keeps in communication with Earth. This whole assembly stays together during the 7-month journey to Mars. We'll need to adjust our path along the way. We do this with the thrusters on the side of the cruise stage. This is called a trajectory correction maneuver, or TCM, and there are several of them on the way to Mars. Landing on the surface of Mars is nothing short of intense. They call this EDL, or Entry, Descent, and Landing, often nicknamed the 7 minutes of terror. This is because if anything goes wrong, then we'll likely fail to get the rover safely to the surface. At the time of landing, it will take about 11 minutes for any signals to reach Earth. This is, of course, traveling at the speed of light, the fastest that we know how to communicate. It doesn't seem very fast, does it? 11 minutes is a long time. To put this in perspective, from Earth to the Moon, light takes just over 1 second to get there. When the Apollo astronauts were landing on the Moon, NASA could communicate with them almost in real time. It would take about 2.5 seconds to receive a reply. On Mars, this is completely different. If something goes wrong during the landing, Mission Control won't hear about it for 11 minutes, and any reply would take another 11 minutes to get all the way back. By this point, it will already be over, either a safe landing or a crash. This means the computers, electronics, and the software must be smart enough to do everything on their own. EDL, Entry, Descent, and Landing. Let's follow this through step by step. About 10 minutes before entering the atmosphere, the cruise stage is detached because it's no longer needed. Small thrusters on the back shell will now be used to steer the spacecraft. Next comes atmospheric entry. The heat shield will protect the rover during this time. Once we get about 11 kilometers above the ground, then the parachute can deploy. It uses a technology called range trigger, which finds out how close we are from the landing site and then deploys the parachute at just the right moment. Next step is heat shield separation. For the first time, the Perseverance rover can now see the Martian surface down below. Now we use terrain relative navigation. The rover will be taking pictures of the ground beneath it and comparing these to maps of Mars. This will be used to safely steer the rover towards the intended landing site. Next comes back shell separation. All that's left is the descent stage and the rover. The rockets on the descent stage fire up to slow us down as we get closer to the surface. Then the rover separates but still attached by some cables. They call this the sky crane maneuver. The final part everyone is waiting for, touchdown. The cables are cut and the descent stage flies off into the distance for a crash landing far away from the rover. Now it's time to check out the rover's systems, deploy the mast, and then the robotic arm in the very front. The main purpose of the Perseverance rover is to look for signs of life. It landed in Jezero Crater, which, billions of years ago, used to be filled with water. Where there is water, there is usually life, or at least signs that life existed in the past. Perseverance rover has an array of advanced scientific instruments to study the surface of Mars. If you remember from earlier, the rover is enormous. It's about the size of a car. The main body of the rover they call the Webb, Warm Electronics Box. Then you've got 6 wheels, 3 on each side, that are made of aluminum. The front and back wheels can turn, allowing the rover to spin a full 360 degrees. The suspension system allows the rover to travel over rough terrain. You never know what kind of obstacles you're going to come across on Mars. But to be more realistic, the rover would be going about this fast. It has a top speed of 0.1 kilometers per hour. The slow speed is mainly for the safety and stability of the rover. This is the remote sensing mast. This is the place where you'll find some of the cameras and sensors of the rover. It's just a little taller than the height of a human. The idea is to give us a similar view of what a person would see if they were here on Mars. This big circle up on top is called the supercam. It's basically a laser that can identify chemicals in rocks from as much as 7 meters away. This is the mast cam Z. These are the main cameras on the rover that can even take high-definition video. Navigation cameras are used to help the rover safely drive on the surface of Mars. Right below is the Mars Environmental Dynamics Analyzer, or MEDA. This is studying the weather and atmosphere on Mars. The rover has 2 microphones, one on the mast and then another on the side of the rover. Then we have the HazCams, which is short for Hazard Camera. There's some in the front here, but also in the back. Like the name says, these cameras help avoid hazards and obstacles while driving around on Mars. The power source for the rover is called the Radioisotope Thermoelectric Generator, or RTG for short. It's a nuclear power source. The decay of radioactive elements generates heat, which can then be turned into electricity. Some of the previous rovers used solar panels to generate power from the sunlight, but this doesn't work at night, and if too much dust gets on it, well, then it's game over. Both Curiosity and Perseverance use the RTG, which means a lot more flexibility in regards to power. This is RIMFAX, or Radar Imager for Mars Subsurface Experiment. This uses radar waves to study the ground up to 9 meters below the surface of Mars. Then there's MOXIE, Mars Oxygen In Situ Resource Utilization Experiment. This takes the carbon dioxide on Mars and turns it into oxygen. This kind of technology will be very important once we start sending humans to Mars. And of course the robot arm in the very front of the rover. This has a few tools at the end with some really big NASA acronyms. So here we go. Pixel. This helps to determine what chemicals make up the rocks on a very small scale. Watson, another powerful camera to see the rocks with fine detail. And then Sherlock. This provides fine-scale imaging. At the end of the arm is the coring drill. This is capable of drilling and collecting samples that will be stored on board the rover. Then it will take these samples and place them inside of the rover. A future mission is planned to take these samples from the surface of Mars and return them to Earth so we can study them further. So how does Perseverance communicate back to Earth? The best way is to use the Mars Relay Network, which consists of several satellites in orbit around Mars. These were launched long before Perseverance got to Mars. These satellites are also used for science and to communicate with other rovers that are also on Mars. For example, one of these satellites is called the Mars Reconnaissance Orbiter. So Perseverance can send data to the satellite, which will then send it directly back home to Earth. On the surface of Earth, NASA uses massive satellite dishes to communicate with spacecraft throughout the solar system. This is part of the Deep Space Network. There are 3 main locations for these satellite dishes: Goldstone, California, Madrid, Spain, and Canberra, Australia. No matter which way the Earth is facing, it will always be able to receive signals from Mars or other distant places in our solar system. Perseverance has 3 antennas on board. The UHF antenna, or Ultra High Frequency antenna, this communicates directly with satellites above, primarily used to send large amounts of information. The High Gain antenna transmits directly to and from Earth, and then the Low Gain antenna, mostly used just to receive data from Earth. Of course, we can't forget about Ingenuity. This is the helicopter that was sent to Mars along with the rover. Now, where would you put a helicopter on the rover? Look closely. You'll see a little tiny black compartment right here. This is where it was stored. About 2 months after landing, the helicopter was finally deployed onto the surface. The process took about a week to complete. First, the cover is removed and we expose the helicopter. Then it's unlatched, carefully folded down, the legs come out, and dropped onto the surface. Perseverance can drive away and Ingenuity can start to absorb the sunlight on its solar panels. The helicopter has two rotors that rotate in opposite directions. On Earth, most helicopter blades spin at only a few hundred RPMs, or rotations per minute. For a helicopter to work on Mars, we have to spin the blades a lot faster. This is because the air is much thinner here. The first test flight of Ingenuity happened about 2 months after landing on Mars, the first helicopter to fly around on another planet, and it turned out to be a huge success. As of this video, there's been a handful of flights and Ingenuity is still operational. Perseverance paves the way for future missions where we will hopefully be able to return Martian samples back to Earth. And of course, the next major milestone, sending humans to Mars.